Our NumPy package is already completed, and now we are going to start the pandas. Okay, as the NumPy package is mainly for the numbers, but pandas is for the tabular data. So whenever we need to operate with some table kind of data, then we work with this pandas. Okay, I guess screen share has been stopped. Why? Give me a second. I'll share the screen again. Okay, is my screen visible now?
Not yet. Yes.
Okay. Basically, Pandas package is very much fast and efficient to handle the data frame. So data frame is when I say data frame is basically a combination of rows and columns and different types of data are there in the data frame, right? So to use the package, we use import pandas as PD, so it will help you to import the package. Now there are multiple things are there. First of all, there is import NumPy as NP and Pandas as PD. We have taken these two package, and what we are doing is we are just taking two lists, right? So one has India, France, and England, and another one capitals has New Delhi, Paris, and London. Okay. Now what we are doing is we are simply converting this first package, this first list into the NumPy array. Right, so for that we use np.array and capitals. So this I am executing. So now you can see this this is by this you can easily convert into numpy array. We have already seen this. Okay, now if I want to convert the same into the pandas, so pandas series, so what we have to do, we have to do pd.series. So pd.series will convert this capitals into uh, will convert this capital into the data frame. So you can see here, I am just giving data is equal to capitals, right? So when I have given this data is equal to capitals, so now that Pandas, it has converted this entire data in form of series, and this is SR1. Okay, and now if you try to print this SR1, so it will print like this. So now this is not a normal list, it is a panda series, and panda series is visible in this way. But if you follow the indexing wise, it will do the same thing. So the first, so this value is at 0 index, this is at 1 index, and this is at 2 index. Now what extra can you do with this is you can assign the index also for this, right? So what I'm doing is pd.series and the data is equal to capitals, and here I'm giving index is equal to countries. So now as soon I assign this index is equal to countries in data into capital, so what it will do is in place of this 0, 1 and 2, these countries will come. So India, France, and England will come, right? So let me execute this. So now you can see the entire series. If I am printing this X, so it is printing this India, New Delhi, France, Paris, and England capital, England, London, right? Now, if you want to use the default indexing, you can use the default indexing. So defining index like this does not mean that default indexing will be disappear.
Right. I didn't hear you.
Default indexing will not. Sorry.
Okay. Okay. Yeah, yeah. Go ahead. Your voice was breaking.
Okay, okay. So with this, what will happen is additional indexing is created, and the default indexing is also active, and additional indexing will also be active in this case. Okay. So,
Okay.
so now what you can do is, suppose I am taking, if I try to check what is the type of this, so you can see here the type of this is pandas core series and series. Okay, pandas dot core dot series dot capital S series. Okay, so this is the type of this. So till now, what when we were using type, so it was giving integer or a string or float or boolean. Uh, in case of list tuple, it was returning list and tuple. In case of NumPy array, it was returning the NP array. But now it is returning core pandas.core.series dot capital S series. Okay, so this is how our pandas series is created. Right. In the same way, I have this dictionary over here. So in dictionary, there is the index and value com combinations are there. So when I use this dictionary as a input to create the series, you can see I don't need to specify the data and the index in a separate way. You can see this is the A, B, C, D, E, F, G, H. These all are the indexes, and when I see my PD dict under of E, it is returning me that, and the same thing is returning with the default indexes as well. So the defining new indexes does not eliminate the default indexes. Default indexes will remain as it is. There will be additional indexing things will come. Okay. Okay. Now,
Yeah.
now there is print type of dictionary. So this is PDDict. So you can see here, PDDict is not created. Let me create this. Yes. Now this is pandas.core series. Okay. Now how you can do the indexing? That is the same way as we were doing earlier. So you can do the same kind of indexing over here. So for example, 8 onwards, all elements. So sorry, it is giving the shape. This is the eight elements, and in my series, it is printing this A B C D E F. Okay, and the same way, the indexing will work like fifth element you want. So fifth element is coming as 60. So element. So this is 0, 1, 2, 3, 4, 5. So this is the fifth index. So this value is coming as 60. In the same way, I want from starting till 3 minus 1. So it is giving me A, B, C. I want to start from 3 and go till 7 minus 1. So it is giving D, E, F, G. Okay, then only E index. So this is there. So multiple indexes you want to take, so you can give it like this, right? So just see, when I am giving the multiple indexes, I am giving in form of list, not just the indexes. When I have to get the individual indexes or group of indexes or series of indexes, I am giving like this. Right? This is 3 to 7. So 3, 4, 5, 6, 7 all will come. This is just T. But here I am getting the random indexes. Right? So when I am giving the random values in form of indexes, and then that needs to be supplied by supplied by a list form. Okay, in the same way, this is giving random indexes A, C, E, right? So it is giving me the same values. Okay, so in this way, you can get the multiple index values. Now the series is created. What I'm doing is my series plus my series. So what it will do is the number at one index will be added with first index in this, first index of this, and first index of this will be added. Second index of this and second index of this will be added. Third index of this and third index of this will be added in this way. Okay, whenever you are going doing this plus operation. Okay, I'm doing my series divided by 2, so all elements are divided by 2. Okay, so these all are some operations and slicing operations and accessing operations that can be done on the Pandas series. Is it clear?
Yes.
Okay, now now data frames. So in case of
So
data frame, so
basically, these pandas are used to keep it, keep the data in structural way.
so pandas are basically to keep the data in tabular form. Okay, so tablet
Mm.
tables will come in a short while. Just wait. Tables will come.
Okay.
Right now, we are just learning the basics of this,
Yeah, yeah.
and mm, now the data frames is getting started. So, what is data frame? So, data frame is a 2D data structure. It is a two-dimensional data structure to align the data in the tabular format. So, when data is aligned in rows and column format, so it can be stored in means that there can be any kind of data types, like it can have the string also, it can have the integer, it can have the float, it can have the boolean. Okay, so to create a data frame we use simply pd dot data frame function. So pd dot data frame function is helping us to create the data frame, right? So let's say we have this apple, banana, coconut, and dates, and this is a list. From this list, if I am going to create a data frame, what I'm doing is pd dot data frame, and inside this I have given this fruits. So what it will do is it will simply create a data frame for me. Okay,
Mm-hmm.
so let's execute this part. So you can see here it has just printed the data frame for me. Let me um let me out this thing first. Here now I'm executing this. Okay, let me execute this first. So you can see here it is coming as this data frame is printed. So you can see it is apple, banana, coconut, and dates, and indexes are 0, 1, 2, 3. Okay. Now you can see here it now this is coming in column format, but there is no heading of the column. It is coming as 0. So if I want some name to be given in this, so here this is the code. Okay, so what we can do is here the same thing with fruits. After that, columns is equal to. So it will define the name of the column as fruit. So I'll just execute. So now you can see instead of 0, and this is coming as fruit.
No
Okay,
need for print statement.
sorry.
Print statement. No need for print.
No. For this print, if you will use the print statement over here, so it will come like you can see. It will come like this. Okay.
Mm-hmm. Mm.
But if you will use the data frame name directly, so it will be coming like this, a
Okay.
little graphical format.
Okay.
Okay. Now we'll create the data frame from the nested list. So this here there is list inside list. So this is for Rick's data. This is Morty. This is Summer, and this is B. Okay. And now what I'm doing is people underscore df is equal to pd data frame and inside that people, right? So when I'm doing this, what will happen? Let me make this as comment, and I am executing this. So you can see this. It is giving me all the values in one rows. So this is one row. This is one row. This is second row. This is third row. This is fourth row. Like this, it is coming. Okay, so you can see here this is coming now. Right now, here there is column name as 0, 1, and 2. So you need to define the column names like we defined over here columns. Here also you can define the column names, right? So these column names will be name, age, and blood group. Okay.
Okay. I don't hear you. Are you talking? I don't hear you.
It's clear for you.
Yes, I don't hear you. I thought you were not talking.
Till where you I was audible.
Uh, Data frames from nested list.
Okay. So here you can see I am creating this data frame using this list. So there is one list element one is this, list element two is this, list element three is this. Now I am going to convert this into the data frame, right? So what it will do is now I'll just do this comment, and now I'm executing this. So as soon I have executed this, so you can see here it is coming. This entire row in this value has come at first row. This entire value has come at second row. Then someone is in third row and big in is in fourth row, right? And here at the heading you can see 0, 1, and 2. Okay, so there is no column name coming. If you want to assign the column name, you can use this statement. So three columns are there. So I have defined three column names: name, age, and blood group. So I'll just define this, and you can see this is coming as name, age, and blood group. Okay, let's suppose I give a name like XYZ at 4, and if I try to execute this, it will generate an error. Why it is giving me error? Because it is finding just three columns over here, and it is getting a one extra column name. So that's why it is giving error. So you have to keep in mind with this situation. Okay.
Okay.
Now creating data frame from the dictionary. So simply I am taking the names over here, age over here, and blood group over here. And here then I am executing this. So you can see here, this is coming as uh, directly with the name, age, and blood group. It is coming over here. Okay.
Okay.
Okay, now we are going to get some external files for this. So to get the external file, CSV file is there. So for CSV file, you can use this read underscore CSV. You know CSV, right?
Yes.
Okay. So here I am just giving pd dot read underscore CSV, and here I am giving this data. So this is the data location in my system.
Mm-hmm.
This is the location of data in my system, and I'm just using this over here, and I am executing this. So now you can see here, I have got the data of this wine. So
Oh,
year of production.
your screen is not visible. Your screen is not visible.
What is this here? Okay, so this is pd.read underscore csv, and here this is the location of data in my system, and I'm just executing this over here. So you can see here I have got the data. Now let's explore what is there in this file. So how to explore the attributes of this file. So here this is I have this data frame name dot info. So this will return how many columns are there, how many rows are there, then how many not null values are there if they are missing values. So you can see there is missing value in price, and that's what it is showing over here. Just 26 over here. Okay, then data type of this. So this is integer, then float, integer, float, integer, integer, float. So it is giving me everything, how many float columns are there and how many integer columns are there. Everything is being returned in this with this info, right? In the same way, if you have to get a JSON file, right? So for JSON file also, so you can give command as read underscore JSON. So for CSV, it was read underscore CSV. Now for JSON, read underscore JSON file. Okay. So here when I execute this, when I execute this, so you can see here, it is importing this file. In the same way, you can import the Excel file also. So for Excel, there is the XLSX it will enter, and then along with that, I have to give the sheet name as well. If there are multiple sheets are there, when multiple short sheets are there, you need to define the name of sheet at the end. So this will work with read underscore Excel. Okay, so it will read the Excel file. Now, if you want to see that information about this file, so simply Excel and data
So
frame name.
is it has any kind of memory level until, I mean, it can only read up to this much memory, or is it has anything like that?
I
I
didn't get
mean,
your
Pandas.
question.
So you have given the address for Excel file, and it is reading those Excel file, correct?
Yes, yes.
So is it has the this file should be have this much memory only, this can read up to this much,
No, no,
or
no.
10,000 lakhs of data, millions
No,
of data is any.
there is no limitation in Python. Python can read any amount of data. Excel has the limitation, but
Mhm.
Python has not any limitation. It can use any, it can read any amount of data.
Okay.
That's why it is much more powerful tool than Excel. Excel is also a good tool for the data analysis, but this Python is much more powerful than that.
Okay.
Okay.
Mm-hmm.
Now, so this is what it is. Now, if I want to see the info about this file, so I'm just giving data frame name dot info. So it is returning me how many columns are there, how many rows are there, is there any missing value, every information it is giving me. Okay. Now, if suppose we have the CSV file, and CSV file where values are separated by semicolon. So CSV is for comma separated. But if something changes, so you can give this semicolon also in separator, right? So once you give the separator as semicolon, it will pick up the semicolon and it will read the data file according to that. Okay.
So the what is separated by semicolon, like state and city,
Data
or
data is separated.
separated? Okay, all right. Okay, okay, got
Everything is
it.
separated by similar
By
semicolon
okay,
only.
okay.
Okay. When you have to
Mhm.
read the data from the web, that also you can use. So I'm using this from web data. Okay. So now how to see the different attributes of the data frame. So if you want to see how many rows, how many columns are there, simply data frame name dot shape. If you want to see how what all data types are there, so web means data frame name dot d types. It will return all the data types existing inside the data frame. Then webdf.info, I have already discussed. Then you want to count all the values, all the non missing values. So just I'm like people underscore df and 4 I'm taking, and count I'm taking, so it is returning me that. Okay. Then indexing you want to see, column names you want to see. So for indexing, just data frame name dot index, data frame name dot column. Like this, you can get how many rows are there, how many columns are there, from where index is getting started, from where indexes are getting end. Okay. Then now, suppose if you want out of these four columns, any column you want to set as the index. Suppose you want to set the name as index, so you can simply set people underscore df dot set index. So as soon you use the set index, it will convert that particular column in form of index. Okay, clear?
Mm-hmm.
And then in the same way, now you want to add some column, or you want to select any column, or you want to delete any column. So you can do that. So simply, if I want to add a new column, so people underscore df of blood group I have given. So now you can see a new column is added, and if I add this, you can see here this blood group, and the score has been added over here. Okay, in the same way, if you want to create a new column using some existing column, so I suppose I want to do the multiplication of this column and this column. So I am just doing prod is equal to and score into age. So it is returning me the multiplication of 60 and 10, 610 and 990, 45 and 7, 315 and the at between age sorry, yeah. So you can see here how easily I can compute value of new column using the existing existing fields in the data. Now if you want to remove something from the data, if you want to drop any column, right, so you can drop that column as well. I'll put this sum as well because further things are connected. Okay, so now I want to remove this column sum. So what I can do is I'll just remove this column using drop. Okay, and with this drop, what you have to do, x is equal to 1, because I am going to remove and do some operation on the um, columns, right? So that's why x is equal to 1 is required. If I am supposed to do any operation on the row, then x is equal to 0. Okay. Now next is in place is equal to true. So what this in place doing is, in place is equal to true means it needs to be deleted permanently. Suppose if I do this in place is equal to false. So what will happen? You can see here. Um, um, people underscore df is not created. Yes. So now I'll just remove this so you can see here what's happened. What happened? People dot drop. Some does not exist.
You already deleted, so you have to again
No,
run
no.
the.
This is sum, capital sum I am using over here. This is capital sum. Now it will delete. Okay, so you can see here. This is now the capital sum column is deleted. But if I print over here, you can see here this capital sum has come. Okay. So in place is equal to false means it will remove it temporarily and it will show the remaining data, right? It will not show this particular column that is dropped because it is dropped temporarily for this existence only. But after this, again, if I am printing, you can see here some column has again got back. Okay.
So false means it works as it is, and then true means it removes, right?
Yes. So true, when I'll do this as true, so it will not show any output over here. and it will remove it permanently. So when I execute this again over here, now you can see it is not showing that capital S wala sum.
Okay, so if you want to create again, you have to create it and then only you can execute, right?
Yes. Yes.
Okay.
Okay, I'll just do this. Okay. Now if you want to remove any entire column using the del keyword, so with del keyword you can remove the entire column. Suppose I want to remove the score over here, so I can do that by this. Okay. Then if I want to set any column as index, so that I can using set underscore index. Okay. Then these all are the same thing. I'm using drop statement over here for this. Okay. Now indexing in data frame. So you know how indexing works. So in the same way, indexing works in case of data frame as well, right? So now if I want to get the location of 0 to 4, so you can see this, the first part is for rows and second part is for the column, right? So I want the indexes rows from 0 to 4 and column from 0 to 5. So it will return me in that way as output. So you can see here it is returning me I log 0 to 4 and 0 to 5, it is returning me. Okay, it is returning me this. Okay, and when I'm using this blank over here and this 0 to 3. So it will show me first three columns only and all rows because nothing is defined over here. So it will show me all rows. Okay, so it has shown all the rows. Okay, and now from 0 to 4 rows only and all columns. So it will show me that. Okay, so this is using ilog. Okay, so ilog statement is for doing the accessing using the indexes in data frame, right? Second is log. So what log is doing is suppose I want it from 10th onwards, so it is doing me that. Okay, then you can see here now I want the things with some condition, right? So condition is like in this uh, in this market underscore df harvest rate is greater than 200 and market and age is less than 20, and I want this for AGST to age. So here you can see I am applying this part on the rows only, right? Understood?
Mhm.
So uh, wherever this market this harvest train will be greater than 0 and market DF will be under age will be under 20, it will show all that data. Okay, okay, and then the same way all the rows will from here and then in the columns AGST onwards. So it will show me that AGST will be first column and the remaining column will be after that. Okay. Then merging and concatenation and appending of the data into the data frame. Okay, so let me take these two data frames. This is one data frame, this is second data frame, and I'm printing this. So you can see this is DF1 and this is DF2. Now I am going to perform a join operation with these two data sets, right? So, how join operation will work? So, join operation, first of all, let me just concatenate the data, right? So, concatenation will done using concat function. Concat with data frame 1, data frame 2, and x is equal to 0. So, what this data frame will do? These first of all, data frame one will come, and then data frame two will be applied once this data frame gets over. But here the catch is access is equal to zero. So access is equal to zero means it needs to be joined row wise. So once the rows of first data frame ends, the rows of second data frame will start. Right, so that's what is the row wise. If I do it x is equal to 1, so it will join column wise. Okay, so here I will write this x is equal to 1, so it is showing me the column wise. So now you can see there are repeated names are there. So here is ID, here is ID, here is also name, here is also name, and here is also subject, here is also subject. So now names of the or names of all fields are 2, 2. Okay, so now if this you want this to avoid, then we have to use the merging of the data. So right now we were not merging the data, we were just concatenating the data. We were joining the data of one table in front of other table. Okay,
Okay.
clear it?
Yes.
Okay,
Your screen got closed.
again. Mm, Okay, now instead of concatenating, I am joining the data based on some key. So based on some key, when we'll join, this will called as data merging. So in the case of merging, what it will do is it will find a common key between both data, right? So now suppose there is we are joining based on subject. So here you have to write pd dot merge, then left file, this is df1, and then right file, that is df2, and then third one is on. So this on will consider the joining key on which base joining between both tables will be performed. So when I am doing this on is equal to sub, so what it will do is it will find the common values from both tables. So you can see this is sub 2, sorry, sub 3, sub 4, sub 5. These all are the common values in both, right? Sub 3, sub 4, sub 5, these all are the common values. So you can see here where it is, huh? So sub 3, sub 4, and sub 5 are coming, and then corresponding values in their respective table is are also coming. So ID X and name X.
Your voice is breaking. Not audible. Breaking. I don't hear anything.
Clear now?
So your voice is breaking. It's not
Till till
audible.
where you till where you were
Yes.
able to listen that?
Yes. You were the merge.
Okay.
Oh, again, it's breaking.
So here it is finding the common key based on hello. Hello, can you hear me now?
Yes.
Can you hear me now?
Yes. Yes. I can hear you now. Yeah.
Okay. So here now you can see this is on condition I am using. So in on I am using this sub. So whatever the common values between both tables. So you can see this sub 3, sub 4, sub 5 are the common in both table. So those will come. So you can see only sub 3 and sub 4 and sub 5 are there. And then corresponding values in X table and corresponding values in Y tables are here. Okay. So by default, this is called as inner join, where only
Mm.
common values takes place in the final output.
Okay.
Okay. Then if you want to change this straight, so you can try the left join, you can try the right join, you can try the outer join. So there you have to write how. This additional parameter has to be written, that how you want the joining to be performed. So when you it will show the NaN. So you can see here it is starting from sub 1 to sub 7, and in sub 3, sub 4, sub 5, all values are there. Okay. In case of sub 1 and sub 2, here in Y table it is NaN, and in case of sub 6 and sub 7, in the X table there are NaN values are there. So wherever there are common values are existing, it will take values from both tables, and wherever the common keys are not existing,
I don't hear you. Wherever the common keys are not existing? Oh no, I don't hear you.
sorry, can you hear me?
Oh, no,
Hello,
yes, no.
your voice is not now not coming.
I can hear you now. I can hear you
Oh,
now.
okay.
So wherever the common key is not existing,
Hmm. Where see, you can see the sub 1 and sub 2. Sub 1 and sub 2 are in first table only. So no, their corresponding values are here. But it is not there in second table, so NaN are coming. Okay, in the same way, there is sub 6 and sub 7. So these common values are, these values are existing in second table.
mhm, okay.
Okay, so this is what is the joining. So Shamila, I have another session, so I need to leave. We will cover the remaining part in next session.
Will
And
you be available in the weekdays?
tables. So in second table values are coming, but in first table it is coming as NaN things.
No, no, I'm asking, will you be available on weekdays? Kushal, you
Because
hear
of my
me?
office.